So let's do some Chapter 2b notes before you jump into the 2b homework. There's no handout for this, so you can just either take notes on your own and pause when you need to, or just watch. Um, all of the main theorems and algorithms that are in this section are already on your 2b handout, so it's just up to you if you want to do the examples with me or just watch. So this first example that I'm going to do will lead to this division algorithm at the bottom of the page here. Um, so it looks like a weird example, but really what it boils down to is it's a division problem. I give you an F, I give you a D, and by the way, D here stands for divisor. That's why, and you'll see this in a lot of the textbook problems, it's divisor. Q is quotient. If you remember, the divisor is the thing that's like, it's the denominator in a fraction, in a division problem. The quotient is the answer you get, but sometimes you're left with a remainder too. So let me work this out, and then you'll see how we can write it in this form. So really what this boils down to is x to the fourth minus 3x cubed plus 6x squared. Now there's no x term, so I'm going to write plus 0x plus 6 here. And then I'm going to divide that whole thing by the divisor, which is x squared plus 1. But again, I'm going to write plus 0x as a placeholder, and then plus 1. Okay. So I'm going to go through the long division somewhat quickly. If you don't feel comfortable with it, you can reference this video. You can pause this video when you need to. You can reference section 2.4 on page 214 of your book. Or you can find, I think, if you search for 2a or long division on the YouTube page, then you should be able to find another example worked out more slowly. So this term here is going to be x squared. When I multiply that by everything over here, the divisor, I'm going to get x to the fourth plus 0x cubed plus x squared. And then I'm going to subtract that out. And so when I subtract that, I'm going to get negative 3x cubed. Remember, these guys will cancel, which is good. Plus 5x squared. And now I can bring down the next term, plus 0x. So the next term that I'm going to use is minus 3x, or negative 3x. So when I multiply that over here, I'm going to get negative 3x cubed plus 0x squared minus 3x. And now I'll subtract again. These will cancel. I'm left with 5x squared minus 0x squared, which is just 5x squared. And then 0x minus negative 3x, which is positive 3x. Okay, so let's do this one more time. I'm going to bring down the 6, and the number that will work here is a positive 5. If I multiply that, I get 5x squared plus 0x plus 5, and then I can subtract this. These will cancel. I've got 3 minus 0 is 3 with an x, and 6 minus 5 is 1. So my remainder here is 3x plus 1. Okay, now if you remember long division, how it works, this thing on the inside, the dividend, as it's called, is the same thing as this part, the divisor, times the quotient, plus the remainder. Okay, so let's write it that way. So if I write it like that, I've got x to the fourth minus 3x cubed plus 6x squared plus 6, I'm leaving out that 0 term, equals the divisor, I'm leaving out the 0 term again, times the quotient, plus the remainder. Oop. There we go. So let me shrink this down. Lost the negative. Oh, well, whatever. Let me just... There. Okay, so if we look at this, this thing right here was my f of x. It equaled my divisor, which was d of x, times my quotient, which was q of x, plus my remainder, which I called r of x. So we've written it in the form that we need to. So, if you're looking for the q of x, well, here it is. If you're looking for the r of x, there that is. Okay, one thing to notice, the degree of r of x, notice that that's less than the degree of d of x, right? The remainder should have a degree that's less than d of x. In this case, the degree of r is 1. That's less than the degree of d, which is a quadratic. That's 2. And if it's bigger, then you haven't divided enough yet in your steps. You should just keep carrying out that long division until it's smaller. Otherwise, you've got more steps to go. Okay, so if we look down here at the division algorithm for polynomials, that's what this is basically just saying. If I give you an f and then something to divide it with, and f is going to be the bigger degree polynomial. Typically you want to divide bigger by smaller. Then there are going to be these other things, the quotient and the remainder, and you can write out the thing this way. Okay, and it says here r of x is going to be 0, so sometimes you won't get a remainder, or the degree of r is less than the degree of d. Okay, that's what we just set up here. That's what we just noticed. Okay, so that's the division algorithm. So what I want to do is look at an old homework problem that you did, and it was from 2A number 8. And this is the solution to 2A number 8. Now this answer here, you had to do 2x to the 4th minus 5x plus 7x squared minus 3x plus 1 divided by x minus 3, and then write it in two different forms. This is polynomial form, and it's the form that's just stated here in the division algorithm. So this was your f of x, essentially. I don't remember if these are the same terms that were used before, but this is the d of x. This was the quotient that we got. And this is the remainder. Whoops, that's not a plus. This one's a times. And then plus the remainder, right? Let me write r. Now, normally I'd write r of x because that's what it says up here. But r of x is a constant. If you look at the divisor, that's got degree 1. So that means that r of x either doesn't exist, but it does here because it's 82. So it's got to have a degree that's less than 1, which means it's got to have degree 0. Degree 0 is the same thing as saying a constant. So if I'm dividing by a linear term, an x to the first term, then I'm going to be left with a constant or nothing, right? Either a constant or nothing. So instead of writing r of x, that's sort of overkill. I'm just going to write r, okay, because now it's a constant. Okay, so what do I want to do with this? I kind of want to play around with this a little bit to show you one nice result. So notice that I'm dividing by x minus 3, right? That's my divisor. So what I want to do is I want to look at, let me write f of x out here. So I know f of x equals this thing, but I know that f of x also equals everything else, the d of x times q of x plus r. So let me write that out. Okay. Now, there's one x that's really convenient to plug in that will cancel out a ton of stuff, and that x is going to be 3. Because if I plug in f of 3, then that first term becomes 3 minus 3, which is 0. So it doesn't even matter what's in here. I don't have to evaluate that at all. And then I've got plus 82 at the end. So this is going to turn into 0 plus 82, which is just 82. So f of 3 is 82, which was my remainder. So what I want to do is I want to generalize this result. Okay, and this works for linear terms when I'm dividing by a linear term. So x minus something, and in this case we're going to look at linear terms where the coefficient is 1. So 1x minus something or 1x plus something is our d. So let's look at the general form here. I'm going to generalize this, and then we'll talk about it and why it's useful. So if I've got f of x equals d of x times, whoops, not g, q, quotient, plus the remainder. Okay, now I'm going to force d of x to be a linear term. So I'll write make linear with coefficient 1. Okay, so then, so then that's going to mean, f of x equals x minus something, and I'm going to call the something k here, times q of x. I don't need parentheses for that, so times q of x plus, and then since this one's linear, it's degree 1. So my remainder is going to be degree 0, which is a constant. So I'm just going to write r instead of r of x, because I don't need to deal with the x's anymore for r. Okay. It could be that r is 0, but it's still a constant. So either way, it's just r. I don't have to write r of x. Okay. Well, the convenient thing to plug in here that tells me stuff is k, because if I plug in k, if I want to find out what f of k is, then it's k minus k times q of k, and it doesn't really matter what q of k is because this is 0, plus the remainder. So this just turns into 0 plus the remainder, which is just the remainder. So what this is saying is f of k equals the remainder. Okay? So if a polynomial f, right, is going to be divided by, remember, because this is the divisor, if I'm going to divide it by x minus k, I'm going to be left with this phrase here, this statement here, and the remainder ends up being f of k. Okay, so here's the way that it's worded. It's called the remainder theorem. If a polynomial is divided by x minus k, the remainder is f of k. So that's actually kind of useful. Let's use the theorem just to show you how useful it can be. So find the remainder when f of x equals 3x squared plus 7x minus 20, and it's divided by x minus 2. Now, you could work this out using long division, or later on you'll see a video on synthetic division. But in this case, you don't need to really do a whole lot. You know that this is my x minus k. And my theorem up here says if a polynomial is divided by x minus k, then the remainder is f of k. So in this case, k is 2. So if all I want is the remainder, then I'm just going to do f of 2. I'm just going to figure out what f of 2 is. So that's going to be 3 times 2 squared plus 7 times 2 minus 20. And if you work that out, that's going to be, what, 12 plus 14 is 26 minus 20. That's going to be 6. So my remainder is 6. That's much quicker than doing long division on that thing. Okay, so hopefully that makes sense. And let's take a look at one more example. Oh, I forgot the square here. There should be a squared here. I wanted this to be the same as this. So let's find the remainder when I'm taking this thing and dividing it by x plus 4. Okay, so again, this is my x minus k. So that means my k in this case is negative 4. So what I'm going to do is f of negative 4 will be my remainder. Right, so again, this is pretty quick. So it's 3 times negative 4 squared plus 7 times negative 4 minus 20. Well, let's see. This is going to be 16 times 3, 48. And then I'm going to subtract 28, and then I'm going to subtract 20. I'm left with 0. Now, a remainder of 0 is kind of nice, because if I have a remainder of 0, that means that this evenly divides f, right? It's so that forces it to be a factor. So that's actually called the factor theorem. A polynomial function f, whoop. Why is it doing this? Okay, sorry, has a factor x minus k if and only if f of k equals 0. Okay, so so if I try to figure out my remainder, this is driving me nuts. All right, here we go. So if I have some function and I divide it by something and I try and just figure out what the remainder is and I get the remainder 0, then I know that this is a factor of that. All right. So that's the end of the notes stuff here. You do need to watch another video on synthetic division. Synthetic division is a quicker way of doing long division, and it only works with, well, the method that you're going to see only works with linear terms. So, and in fact, it's only going to work with linear terms with a coefficient of 1. So it's only for limited circumstances. Now, the video is going to be from Khan Academy, and you've probably heard of that, or if you haven't, it's a huge collection of videos. So I'm going to post the link on our agenda for that so you can watch it. It doesn't explain why it works, and so I'm going to post a second link that's optional for those of you who are interested in why the synthetic division actually works. I think it's like another 7-minute video, something like that. It's not terribly long, but it really goes through the details. It does a long division problem, and right next to it, it does a synthetic division version so that you can see where those links are. Okay, and then once you're done with that, try the homework, see how you do.